start off looking at gradient graphs and therefore gradient functions. We're going to start off with polynomial graphs. So what we're going to do first of all is just look at a horizontal straight line. So if I maybe make this y equals 3 here, alright, you'll see as I move the gradient here, so what I'm going to do is just look at the gradient. So this will be the gradient at this point here. Okay, and what's going to happen is this point here, this is going to be the gradient, okay? So you see this point A here, we know the gradient is 0, therefore this point B here is on the axis, right, to represent a 0 gradient. So what we're doing effectively is, for this function, you're going to plot a new function, which is plotting x against the gradient. So the y-axis becomes therefore the gradient. So at this point here, A here, you see the gradient is 0. Therefore, that's why you plot this point on the gradient function at 0 on the y-axis, because that is your gradient. So if I animate this, and we move this point along, you see, because it's a linear graph, then the gradient is the same at all points. So no matter where we are on this function, you see, as we move along here, the gradient is going to be 0. Therefore, the gradient function will be this red line here. Okay, so the gradient function for this graph here is going to be 0. Okay, and that's why when we plot this graph, you're going to have the red line along this axis here, along the x-axis, because on the x-axis, that is where the gradient is 0 for this function. So if we were to change the value here, so you have a horizontal line y equals -2, then it's not going to make any difference to the gradient. If you have a horizontal line, the gradient is going to be 0 at all points. So regardless of what value I make y equal to for a horizontal line, the gradient will still be 0. So therefore, the gradient function will be a horizontal line along the x-axis to represent that the gradient is 0 at all points on this function. Therefore, when you find the derivative, the gradient of a constant, that's why it always gives you 0. Okay, so if y equals 5, the derivative of y equals 5 will be dy by dx is 0. So if we now look at a linear graph with a positive gradient, so the graph that I've chosen to draw here is y equals 2x plus 1. Again, with linear functions, you've got to think about the gradient of linear functions always is a constant. The gradient doesn't change no matter where you are on the function. So therefore, if I animate, so this point B again, you see, this is plotting the gradient. Okay, so if you see any point that we've got on this line, the gradient on the line y equals 2x, the gradient is always 2. So therefore, when you draw the gradient function, the gradient graph, then it's going to be a horizontal line along 2. So the gradient function is going to be y equals 2, representing that the gradient on this function is always 2. So when you have the derivative of 2x plus 1, the derivative of 2x plus 1 is going to be 2. Okay, because the derivative of 2x is 2, the gradient of 2x is 2, the gradient of plus 1 is 0, as we've seen before. If we now look at a negative linear function, so the function that I've chose here is -4x plus 2. So again, if you think about what the gradient is of this straight line, the gradient again is going to be -4. Wherever you are on this straight line, the gradient is going to be -4. Therefore, when you draw the gradient function, then it's going to again be a horizontal line representing that the gradient remains a constant throughout this linear. No matter where you are on this linear graph, the gradient is always -4. Therefore, the gradient function will be a horizontal line y equals -4.